Why is everything moving away? Hey there. Welcome back to another episode of The Stuff You Should Think About. I'm your host, G, and I'm so glad you decided to hang out with me for a bit. Today, I want to talk about something that sounds like the premise of a low budget sci fi movie, but it's actually the literal, physical reality of the ground. Well, the space beneath our feet. We're talking about the expansion of the universe. Now, I know cosmology sounds like a big, intimidating word that belongs in a textbook that costs $400, but I promise you, it doesn't have to be. We're just going to chat about the mechanics of space. So grab a coffee, get comfortable, and let's dive into why the universe is currently making itself a lot more room. Okay, imagine you have a balloon, just a standard birthday party style latex balloon. If you take a marker and draw a bunch of little dots on the surface of that balloon, let's call these dots galaxies. And then you start blowing air into it. What happens? The balloon gets bigger, right? As it expands, the distance between those little dots increases. But, and here's the kicker, the dots themselves didn't actually move across the surface of the rubber. They aren't crawling away from each other. The rubber itself is stretching. That's it in the simplest terms, how the universe works. For a long time, back in the early 20th century, scientists thought the universe was static. They thought it was just sitting there, like a giant, like an eternal fishbowl. Even Albert Einstein believed the universe was static. He actually added something to his equations called the cosmological constant, just to keep it from collapsing or expanding in his math. He basically forced the math to show a statistic universe because he couldn't imagine it any other way. But then, a guy named Edwin Hubble came along. He looked through his telescope and realized that the light coming from distant galaxies was redshifted. Now, I'm not going to get bogged down in deep physics, but think of redshift like the sound of an ambulance siren. When an ambulance drives towards you, the sound waves compress and the pitch goes up. When it drives away, the sound waves stretch out and the pitch drops. Light does the same thing because distant galaxies look redder than they should. It means the light waves are stretching out as they travel to us. Hubble's conclusion, everything is running away, and not just running, the space between us is growing. Here's where most people get tripped up. So let's clear the air. When we talk about expansion of the universe, we often hear it compared to the Big Bang. And usually people hear Big Bang and think, oh, so there was a giant space bomb that exploded outward into an empty room. But that's not right. There was no outside. There was no room for the universe to expand into. The universe is the room. The Big Bang wasn't an explosion in space. It was an explosion of space. It was the sudden, rapid inflation of the fabric of reality itself. Think of it like a loaf of raisin bread rising in the oven. The raisins are the galaxies, and the dough is the space. As the dough expands, all the raisins move away from each other, but the raisins themselves, the galaxies, aren't doing the walking. The bread is just putting more volume between them. This is a really important distinction because it changes how we see our space in the cosmos. We aren't drifting through a void. We are passengers on a moving, stretching canvas. Here's why things get even weirder. If you throw a ball into the air, it goes up, slows down, and eventually falls back to the Earth because of gravity. Gravity is the universal anchor. It pulls things together. For years, astronomers thought that the expansion of the universe would eventually slow down because all that gravity from all those stars and galaxies would pull against the expansion. But in the late 1990s, scientists discovered something that honestly freaked them out. The expansion isn't slowing down, it's speeding up. It's like throwing that ball into the air, and instead of slowing down, it suddenly starts shooting upward towards space faster and faster. To explain this, scientists had to invent a placeholder named dark energy. We don't really know what dark energy is. We can't see it, we can't touch it, and we can't measure it directly. We just know that it accounts for 68% of the stuff in the universe. It is the universe force pushing the fabric of space apart. It's like an anti gravity pressure that makes empty space want to grow. So you might be asking, gee, does this mean my car is going to get stretched out on the way to work? Thankfully, no. Gravity is still a very strong force on a local level. Within our own galaxy, the Milky Way, gravity is strong enough to hold our stars, our solar system, and even our neighbors like the Andromeda Galaxy together. The expansion happens in the vast, empty spaces between galaxy clusters. It's a bit like the surface of the Earth. You can put a sticker on a globe. If the Earth were to magically expand like a balloon, the surface area would increase, but the sticker, your car, your house, your galaxy, stays the same size because the local forces, glue, in the case of a sticker, gravity, in the case of the galaxy, are stronger than expansion. It's only when you look at the cosmic scale, the massive gaps between distant clusters of galaxies, that you see the expansion happening. The glue of gravity isn't strong enough to bridge those gaps, so they just keep growing. If you're a fan of what if scenarios, you might wonder how this all ends. If the universe keeps expanding and the galaxies keep moving further and further apart, what's left? The scary or maybe just peaceful answer is the big freeze. Eventually, galaxies will be so far apart that they'll disappear from our view. The light from them will take so long to reach us that it will stretch out completely in the darkness. We'll be left in solitary, cold, dark universe. It's a bit existential, right? To think that we are currently living on a golden age where we can actually see other galaxies, because one day they will simply be too far away to ever be reached or seen again. But look at the bright side. That's billions and billions of years from now. We have plenty of time to enjoy the view while it's still here. I know we've covered a lot of big stuff today: redshift, dark energy, cosmic inflation. Why should you spend your brain power thinking about this when you got actual tangible problems to deal with? because there's something remarkably humble about understanding the scale of the universe. Often in our daily lives, we feel trapped by our problems. We feel like we're in a static, unmoving room where things can only change in one direction. But when you realize that the universe is dynamic, that it is literally opening up and creating more space every second, it reminds you that nothing is truly static. Change is fundamental property of the universe. Expansion is the default setting. Maybe that's a nice way to look at your own life. Even if things feel tight or claustrophobic right now, that isn't the, that isn't the final state of things. The universe is hardwired for expansion. Maybe you are too. Thanks for letting me go on this little cosmic detour with you. I really hope you enjoyed it. Before you go, take a second look at the night sky tonight, or if it's the middle of the day, just look out a window. Try to remember that the distance between you and everything else is a living, breathing, stretching thing. I'm G. This has been Stuff You Should Think About, and I'll catch you on the next one. Stay curious.